All right, everybody. Hello and welcome to this edition of Science in Review. All right, so this week we've talked about several different things that I want to review with you before we go into next week when we take these and we do a little bit more with it. So I've got the properties of matter. I've got mass, weight, volume, and density. We talked about all of these this last week. And mass and weight, I told you, people get those confused. They are very different. So mass is how much matter is contained within an object. Weight is the gravitational pull of that object. So mass doesn't change, weight can change. For instance, if I went to the moon, my weight would be a lot less because so would the gravitational pull on me. But the matter contained in me would still be the same. Now, if I traveled to Jupiter, which wouldn't be real smart, but if I did, the gravitational pull would be much greater on me, my weight would be much greater. However, again, the matter that's within me is the same, so my mass stays the same. Now, volume. We talked about finding the volume of an object. Now, a rectangular prism, something regular like a rectangular prism or a cube, really easy to find the volume. We've talked about that a lot in math. We have length times width times height. Now remember, we had a penny and we put that in a graduated cylinder to find the volume of the penny. So let's take this tennis ball. If I took a graduated cylinder and I put 40 mLs of water in that graduated cylinder and put the ball in there, and then I go to measure it, and it measures 100 mLs. Well, the water that it displaces or moves tells me the volume of the ball. So that would mean that the volume of this ball is 60 mLs. So try it at home with something. If you have a cup measure, just see how much it moves once you put something in it. So put, like say, half a cup of water in and try to put a penny in and see how much the water displaces or moves. Try different objects. Try a golf ball. What about a ping pong ball? So try different things in there to see how much water it displaces. If you do that, you're finding the volume of the object you're putting in the water. Now we've also talked about density. So density we've talked about in very simple terms as being if something sinks or floats. So we're going to do a little experiment on that. And I have two different cans of Coke. I have a can of Diet Coke and I have a can of regular Coke. Now, I'm looking at these two and I'm thinking that because Diet Coke is diet, I'm thinking that this is going to be less dense than the regular Coke. That's just my guess. So I always have to have a guess before I start something so that I have something to compare to my beginning thoughts to what really happened. So I take this great big thing that used to be full of cheese balls and I cleaned it out, and I'm using that to determine the density of these two objects. Now again, I'm doing this very simply. So I'm going to put them both in the water and then see which one is less dense. So I'm going to go ahead and I'm going to start off by putting my Diet Coke in, and I'm noticing it's floating a little bit, and then I'm going to put my regular Coke in, and it's probably difficult for you to see. I'm going to try to lift this up and take it over to you so you can see that the regular Coke is actually going farther down in the water than the Diet Coke. So, on further investigation, because I did do this earlier, I noticed that both of these have the same ingredients except one big difference: the type of sweetener. So the regular Coke has high fructose corn syrup, and the Diet Coke has aspartame. So my guess is that the type of sweetener is causing the pop to be more dense than the other. So I'm going to take my water, and I've got high fructose corn syrup. I bought the dark kinds because it's easier to see in the water. And I want to see, will this float in the water? Is it less dense than the water, or will it sink? So this is my first thing that I want to investigate before I make any conclusions. So I've got my corn syrup, and I'm noticing that corn syrup went right to the bottom of the cup. So I know that high fructose corn syrup is more dense than water. So that might have something to do with this. Now I have nothing to compare it to because I don't have liquid aspartame. Believe me, I looked at the store, they don't have it. So that's one thing that I'm thinking, one reason why it's more dense. Now, another thing I want to investigate before I make any conclusions is the weight. So I'm going to go ahead and weigh both of these. And again, my thought process is telling me that the Diet Coke is going to weigh less too. But I want to make sure. So I'm going to start off, and I've got 100, 200, 300, 400. Oh, that's too much. So I'm going to go back to 300. I've got 360, 370. It's moving. Oh, wait a minute. 370 is too much. 360. Let's go ahead and try. I've got 366. It's starting to move. 367. 368. Okay, 368 and 8/10. So about 369. So about 369 for the Diet Coke. It'll be interesting to see what the regular Coke is. So let's go ahead and mark 369 so we don't forget. 369 for the Diet Coke. So I'll put 369 DC for Diet Coke. Now, what about the regular Coke? Now I have this on here exactly where I had the other Coke, and look at that. It's still, I'm going to need to go further. 370, 380, 390 is too much. 380, oh, 384, nope, too much. 380, it looks like it's going to be about 383. 383. So 383 for the regular Coke. So it even weighs more. So no wonder when we did the density test, the regular Coke was more dense than the Diet Coke because it also weighs more. So the type of sweetener causes it to be more dense and to weigh more. And you can try this at home. The corn syrup I just got out of my kitchen. Corn syrup is used in some cookies and other baking recipes. So you might have some directly in your kitchen, so you can try this out for yourself. Now, another thing that we learned about was the anatomy of an atom. So have you ever had an everlasting gobstopper and you bit into it and you looked in the center and there were little rings of colors? It almost looked like a rainbow inside there. Well, that's kind of like where the electrons live in the atom. So they live in those little shells, and they can move around in their shells, but they can't move to another shell. So if it's in the orange shell, it has to stay in the orange shell. Now, it can move all different ways, kind of like Willy Wonka's elevator. It can move sideways, it can move upwards, it can move downwards, but it has to stay in its shell. So that's what the electrons do and where they are in the atom. They also are negatively charged. Then we have the nucleus, which is at the center. And in the center, we have two other subatomic particles. We have the neutrons, which are neutral, and the protons, which are positively charged. So, in the Khan Academy video that you saw, they talked about the atoms as being like a Lego. And we've got the nucleus, and then on the top, the bumps are like the electrons. So the electrons are what bond the atoms together to form molecules. So the more electrons that are shared, the stronger the bond. So this would not be a very strong bond. This would be a very strong bond. So the more electrons they share, the stronger the bond of the molecule. Okay? So this is what we've learned this week. We're going to take this information. We're going to learn more about it next week. Try out any of these things that you saw here and this will help you kind of solidify your learning so that next week you're ready to move on. I want you to remember, everything you see here, you can do at home. Keep learning, keep sciencing, and keep watching.